Okay, you are given a function k fk equals to this. Show that fk minus 1 is something here. First part is quite straightforward. The boy with a pink color phone with a pink color cover. Can you please keep your phone? Thank you. All right. Yes, you are still talking. fk minus 1. Follow instructions, not too bad. What is fk? You just copy 4k plus 1, k minus 1 over 3k plus 2. What about fk minus 1? You just change all the k's to k minus 1. You get 4 to the power of k, open bracket, k minus 2 over 3k plus 1. Okay, the rest, can I explain the simplification? Okay, explain the simplification. Don't have to copy, but let me explain. Look, all you want to do is to have a common denominator, 3k plus 1, k plus 2. This one, multiply top and bottom by k plus 1. Multiply top and bottom by k plus 1, you get k minus 1 times k plus 1, you get k squared minus 1. This fraction, multiply numerator and denominator by k plus 2. You get k minus 2k plus 2, you get k squared minus 4. You get what I'm trying to say? Then following that is just combining similar terms. Let us assume we are quite good and we can get this. Okay, assume we are quite good lah. And we should believe we are quite good lah. Can? Okay? Done. Consider that done. Okay? It's part 2 that is tricky. Hence, find this, which actually looks exactly like what we have seen. Correct? Yes? So therefore, this is equals to fk minus 1. Is it obvious to all of us that all I need to say is this is summation from k equals to 1 fk minus 1. Okay, I just replace. Quite easy. And this is very obvious. It's MOD, method of difference. Very obvious. Again, you have a minus sign. Again, these two looks similar and successive. So, okay, all good. Or if you understood example 6 and 7, you should know the drill. Write down first three terms, last three terms, cancel, and we are almost done. Okay? See who can do faster, okay? You or me? I do. Okay, then I win. You really want me to win? Actually, I don't want to win. I let you write. I don't even want to write. Okay, come. Do it on your own. First 3 lines, last 3 lines, keep better of cancellation. Write F0 minus F1, okay? F0, don't need to write the whole thing. Okay, wait. F1. Okay, what I mean is this, can I write the first line for you, in case you, the first line should be F1, sorry, minus F0. Can? Don't write what is F1 and what's 0, don't bother. Okay? Okay? F1 minus F0. Okay? Don't write too long. Don't evaluate out, just write F1 and F0. Okay, don't evaluate it. Okay, I said just now, there is no need to write what is F1, what is F0. Even by writing like that, you can see the pattern of cancellation. You don't waste ink by writing so many things. Can? Okay, don't waste ink. Now, what are we left with? We are only left with two terms, which is minus F0 and plus Fn. Correct? Minus F0 and plus Fn. At this point, then you write what is Fn and what is F0. It's a lot easier. Can? So what is Fn? Just substitute, change your k to n, change your k to 0. The rest is evaluation. Consider that done. Is that alright? Good. Very easy, right? Okay. Then I bluff you, right? It's the next part. It's the next part. Okay. Let's go back to the question and answer the question. We have answered this. Can you have attention? We have done this. We have done this. We have not done the deduction. Correct? We have not done the deduction. Okay. Now, you look at what you want to get and what you have shown, what you have found. They look similar but not identical. Of course, correct? Can you have attention, please? I say again, this is what you want to deduce. This is what you have. You are to use this to deduce this. Okay? Can? So, if it helps, then we... Okay, Okay, can we cancel this line, please? Cancel this line. I don't want this line. This one, the equal sign. Okay, I don't want that one. The next one, I will use. Okay, a lot of cancellation. Sorry. Okay. 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 I'm going to start. This is the difficult part. I'm going to go through a bit slowly, but don't take that for granted. Okay, I'm going through slowly because it is not an easy example. This part here, I'm copying and pasting. You don't really need to write, but if it helps you, you can write. Okay? Because this is what we've the answer for the first part of part 2. Okay? Can? Can? Okay. First thing we're going to do is we are going to list the terms one by one for this summation sign. What do I mean? I am going to substitute k equals to 1 here. Yes. And I'm going to say this is 2 square, 4 square over 3 times 4. This is my first term. I will explain why I do it later. Okay? Can we do it first? Then I explain later. Okay? And then I substitute k equals to 2. That means next term, after k equals 1, I have k equals to 2, which is 3 square 4 3 over 4 times 5. The thing is, we don't need to evaluate this number. We just leave it in this unsimplified form. Okay? And then the next term, 4 square 4 4 over 5 times 6 plus dot dot dot. And then we just write last 2 terms will do. N square, that means when k equals to n, big N minus 1, change the k to big N minus 1, I get n square kn. What am I talking about? 4 to the power of n, over n plus 1, n plus 2. And then the last term will be n plus 1, change the k to n. Okay, there's a reason why I do that, okay? I will explain now. This step is important, what I loosely call it as listing the terms. Listing the terms. Now let us observe. Look at this thing that we know. This, we already know that r square for r over r plus 1 r plus 2 summation is equals to this. There is a simplified form for this. We want to make use of this to find this. We know these two must be related, but I don't know how are they related. I repeat one more time. I know this summation and this summation are related, but I don't know how. You see, you can see pattern, right? This is r square, this is k plus 1 square. This is 4r, this is 4k plus 1. You know that means all the r, if I add 1 to all the r, I am good. You follow what I'm saying? So I am going to make this observation. I now can express this whole list of terms in a summation sign with this expression k square 4k over k plus 1 k plus 2. I can cast this thing in this form. I force feed this form in. I force feed this. I know somehow this can be written like that. The issue here is I don't know what is the first term, what is the last term. I just don't know. I will find out now. And if you are fast enough, you can write it on your own. You follow what I'm saying? I say again, for those of us who didn't catch me. First step, I list the terms. Second step, I can see this summation sign r square 4r, and this looks almost the same. I then force feed this thing in. I can say this can be expressed as this. I write this exact expression except that I change my r to k. Get what I'm trying to say? Now, okay, those of us who are falling asleep, please, can you try and keep yourself awake? Now, sorry, this summation line is wrong. Okay, what is the value of k such that I can get this first term out? K equals to 2, very good. Don't just be happy with that, Ken. We substitute k equals to 3 to check whether do I get the second term. Do I get the second term? Yes. K equals to 4, you get the third term. Fine. What about the last term? How do I get this last term? What do I substitute? K equals to big N plus 1. Very good. Okay. Can we please, if you have used different colored ink like me, can you please jot down that I will write the blue colored first before writing the red colored? Because it's very important, the order matters. Because you can't see the red color until you write the blue color. Follow? Okay. And the listing is also important because if you don't list, you also cannot see the blue color and the red color. Okay? Nearly done. This example is nearly done, not completely done. Okay. The result earlier, you look here, we know that this one is equals to this, provided it starts off with r equals to 1. I still cannot use this result. You follow what I'm saying? I still cannot use that line, this line over here. Because this result, I need to ensure that the first term is r equals to 1. But now I have k equals to 2. I cannot use yet. So first thing I'm going to do is to say this is n plus 1, k equals to 1, k square 4k over k plus 1, k plus 2, minus away what? Minus away the first term. Is it obvious to all of us? Yes? I start off with 1, I must minus away first term so that I can start with k equals to 2. So what is the first term? I sub k equals to 1, I get 1 times 4 over 2 times 3. Actually, it's 1 square. Huh? Okay? Okay. Then, are we able to use this result that we have shown earlier? Yes, we can. Think about it. If n is 10, I just substitute 10, 10, 10 here, I get answer. Follow? If n is 11, I substitute 11 here, from R to 11, 11, 11, 11. What if it is a star? If it's a star here, I change this to star, star, star. What if it's a big N plus 1 like this? I change this to big N plus 1, big N plus 1, big N plus 1. Follow what I'm saying? Okay. Then we write. Does it matter whether it's a K or R? Doesn't matter, right? Oh, doesn't matter. It's just a variable. So, we write. Do you need me to repeat? Sorry. I can be a bit naggy. Sorry. No, really. If somebody needs to repeat, I will repeat. Even though some people say no, I don't care about them. Let them be. Do you need me to repeat this idea again? No. Who needs me to repeat? Yes? Anyone? I like to talk, so you nod your head, I will repeat. Okay, nobody. Too bad. Cannot talk. Okay, so it's 1/3. I just change the small n to big N plus 1. Then you realize that this is a plus 2/3 minus 2/3. It goes. Then you will get this answer. Can? Plus 2/3 minus 2/3, you get this answer. Okay? So remember, I just cancel away those things, the cancel out, don't bother, okay? Don't bother. Just use this method. See, now you know why I need to spend so much time. Oh, only 20. I spent 20 minutes on this method. Okay. Now,